Look at your left and right hands. With both palms facing up, place your left hand on top of your right hand. You will see that your hands are non-superimposable. The pinky of your left hand aligns with the thumb of your right hand rather than matching congruently. Your hands are like chiral molecules. Chiral molecules are non-superimposable mirror images of one another. Chirality depends heavily on symmetry. Consider how a plane of symmetry can split a molecule into symmetrical halves. For instance, boron trifluoride has a plane of symmetry that can divide the molecule into two exact halves that mirror each other. Chiral molecules lack this plane of symmetry. For instance, lactic acid has no plane of symmetry where a plane can bisect the molecule to form mirror images. The mirror images of lactic acid here are non-superimposable upon each other. As a result, the molecule is chiral. A chiral center is an atom that has 4 different substituents connected to it. Generally, a molecule with at least one chiral center is chiral, and a molecule that is not chiral is said to be achiral. In organic chemistry, chiral centers are often sp3 hybridized carbon atoms. Recall that sp3 hybridization simply means that the atom is bonded to 4 different groups using one s orbital and 3 p orbitals. When optimizing the structure of one s orbital and 3 p orbitals, a tetrahedral shape forms. The MCAT may ask you to identify the number of chiral structures within a molecule. When you're given a structure, it might be helpful to first identify which atoms are sp3 hybridized to begin the process of identifying the possible chiral centers. Note that any sp3 hybridized carbon may not be a chiral center, particularly if the atom does not have 4 different substituents connected to it. Consider methanol, COH4, for example. Although the central carbon is sp3 hybridized, the carbon is not connected to 4 different substituents as it is bound to 3 hydrogens. Thus, the molecule can create a self-superimposable mirror image of itself and is therefore achiral. This brings us to our first Shem gem. Knowing that a carbon must have 4 different groups to be considered chiral is very important. The test writers will sometimes make you determine whether a molecule has R or S stereochemistry or if it's achiral overall. As such, it's essential to know when a molecule is not chiral. Something unique to chiral molecules is that they are often optically active, meaning they are able to interact with and polarize light. However, not all compounds that contain a chiral center are optically active. In fact, a compound that has multiple chiral centers may not be optically active. In some cases, a molecule may have multiple chiral centers but still be achiral. Mesocompounds, for instance, contain multiple chiral centers and an internal plane of symmetry. As a result, a mesocompound containing multiple chiral centers can still be achiral overall. To determine whether a compound is meso, first check that it has at least 2 chiral centers, denoted by the asterisks in our example to the right. Then, bisect the structure into halves via a plane of symmetry. If the compound reflects the same connectivity of the substituents on both sides, then it is meso. As such, it is not optically active. Like hands can either be left or right-handed, the absolute configuration of a chiral center can be R or S. To determine whether a chiral center has an R or S configuration, first determine the priorities of the 4 groups connected to the chiral center. What does priority refer to? The Kahn-Ingold-Prelog priority rules are conventions that determine the priority of substituent functional groups. Each substituent connected to a chiral center can be assigned a hierarchical priority. The basics are as follows. The groups with the higher atomic numbers receive a higher priority. If groups are isotopes, however, the ones with higher atomic mass receive higher priority. If the groups are the same, then the priority can be assigned by the atomic number of mass at the first point of difference. Any double bonds should be treated as 2 single bonds to an identical substituent. Any triple bonds should be treated as 3 single bonds to an identical substituent. Let's determine the absolute configuration of the compound 3-chloro-1-butene. 3-chloro-1-butene has one sp3 hybridized carbon atom that is connected to H, Cl, CH3, and H2C double bonded to CH, which are all 4 different groups. Thus, this is the chiral center. Next, the priorities of the attached substituents can be determined. Recall that atoms with higher atomic weight receive higher priority. In this case, the chlorine atom receives the highest priority, number 1, while the hydrogen atom receives the lowest priority, number 4. The other 2 substituents are both connected to the chiral center at a carbon atom. Thus, the attached bonds must be traced further to determine the first point of difference. The CH3 group is attached to 3 other hydrogen atoms, while the CH double bonded to CH2 group can be thought of as being attached to 1 other hydrogen atom and 2 other carbon atoms. Thus, the CH3 group receives a lower priority and will be number 3 in our example. We can see the fully prioritized molecule to the right. Determining the priority of each of the groups is the first part of determining R or S. Then, be sure to orient the molecule so that the group with the lowest priority is pointed backward, which is represented as a dashed line. With the lowest priority substituent pointing backward, draw an arrow around the chiral center from the highest priority group to the second highest priority group, then to the third highest priority group. If the arrow travels in a counterclockwise direction, the molecule is in the S configuration. If the arrow travels in the clockwise direction, it is the R configuration. Here's another tutor tip. Note that these directions are reversed if the lowest priority substituent is pointing out of the page. In this case, if the arrow travels in the clockwise direction, the chiral center is in S configuration. If the arrow travels in the counterclockwise direction, the chiral center is in R configuration. Be careful not to make an error here, as it is an easy place to lose points on testing.